If you missed number 1, this is an explanation of how to complete it. What are the solutions for x squared minus 4 equals 0? So when you're looking for solutions, there are several different ways to go about it. You can graph it, you can factor it and set the factors equal to 0. You could use the quadratic formula, or you can complete the square. Those are your options, and it is up to you which method you choose. The simplest way, since you have access to Desmos, is going to be to graph it and find the solutions. So if you type in x squared minus 4 equals 0, notice that nothing comes up. In the Desmos testing version, which is on your final exam, you do not have the ability to type in equations with only one variable. So you can type in just the expression or type it so that it is set equal to y, and that would graph it, but you cannot set it equal to 0 in Desmos. So just know that. But when you graph it, it will come up and you will see your two solutions. So the roots, zeros, x-intercept solutions are -2, 0, and 2, 0. So that's x equals -2 and x equals +2 are your solutions. Now if you wanted to solve this by factoring, what you could do was do the x chart. So before you do x chart, you have to have standard form. So you would have to change this to be x squared plus 0x minus 4 equals 0. So we're looking for two numbers that will multiply to be -4 and add to be 0. So what are two numbers that multiply to be -4 and add to be 0? -2 and +2. So your factors are x minus 2 and x plus 2 set equal to 0. And then you set each factor equal to 0 and solve for x. So those are your two solutions. All right, if you missed number 2, here's an explanation of how to do it correctly. Solve by completing the square. So when you're completing the square, you always want to have x squared plus bx equals c. And we have that, so that is wonderful. So now all we have to do is find the number that we're going to add on both sides. So we have x squared minus 8x, and we're going to add something on both sides. So we just have to find what number we're going to add on both sides. And we find that number by taking half of b, so the b value is -8, divide that by 2, so take half of it, and then square that number. So that gives us -4 squared, and -4 times -4 is +16. So we're going to add 16 to both sides. All right, so that gives us x squared minus 8x plus 16 equals, and then 9 plus 16 is 25. Now we can solve by factoring. So find your two factors. So what are two numbers that multiply to be 16 and add to be -8? That would be -4 and -4. Now we can rewrite this as x minus 4 squared equals 25, and then take the square root of both sides. So x minus 4 equals positive or -5. And finally, you would add 4 on both sides. So when you do that, you get your two equations. So your two equations are x equals +5 plus 4, which is 9, or negative 5 plus 4, excuse me. So negative 5 plus 4 is negative 1. Alright, if you missed number 3, here's an explanation. An equation and the first step in its solution are shown below. What value of h should be used to solve the equation by the method of completing the square? So it's just asking you, what should you add to both sides? So you're always going to notice how they went ahead and moved. This should actually be a positive 9. That's a typo right there. So what should have happened was adding 9 on both sides. And then at this step, we are looking for what number do we need to add to both sides. So you find that number by taking the b value and dividing it by 2 and then squaring that number. So the h value, or the number that you should add on both sides, is 3/2 squared. And when you're squaring a fraction, that's the same as the top number squared and the bottom number squared. So that's 9/4. And that does not simplify anymore, so the number that you would add on both sides is just 9/4. If you missed number 4, here is an explanation of solving by the quadratic formula. So first you need to have standard form. We have standard form. Then you need to know A, B, and C. Okay, just to remind you, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we're going to set up this formula. So we're just plugging in the a, b, and c values that we just labeled. So negative b would be negative 8 plus or minus the square root of b squared, so 8 squared minus 4 times a times c. And then we're going to divide all of that by 2 times the a value. And we just simplify. So that's negative 8 plus or minus the square root. 8 squared is 64 minus, now we're going to do 4 times 3 times 4. It's 48. All divided by 6. And now we have negative 8 plus or minus the square root, 64, whoops, minus 48 is 16, all over 6. So that gives us negative 8 plus or minus 4 over 6. And this is where our two equations come from, or our two solutions. So we get negative 8 plus 4 divided by 6, and we get negative 8 minus 4 divided by 6. And then we just simplify each of those. Negative 8 plus 4 is negative 4 over 6, and that simplifies to negative 2 over 3. Negative 8 minus 4 is negative 12 over 6, which simplifies to negative 2. Number 5, which of the following quadratic equations is solved correctly? So they are solving by factoring, because you can see the set of parentheses there. And these are 4 different equations, so you really have to know your factoring in order to do this. And the best way to just look at the first step of each of these is to just do a quick X chart for each problem that is given. So for A, we need two numbers that multiply to be negative 35 and add to be negative 2. And they said that negative 7 and positive 5 does that. Well, it looks like Negative 7 times 5 is negative 35, and negative 7 plus 5 is negative 2. So this step, at least right here, is correct. Now, if they set each of those equal to 0, the signs are going to change, right? And the signs change because when you do x minus 7 equals 0 and x plus 5 equals 0, when you solve for it, you're going to add on both sides. So you would get x equals 7 and x equals negative 5. So A is solved correctly. Notice that B is not correct because the signs of the factors and the sign of the solution are the same, and they should always be opposite. Okay, so you might be looking at C and thinking, okay, those aren't right because the solution and the factors have the same sign and they should be opposite. And then D looks right at first glance if you're just looking at the signs here. But think about your X chart. So you're looking for two numbers that multiply to be 20 and add to be negative 9. So they have 4 and 5. But 4 plus 5 is a positive 9, not a negative 9. So that's why it's not D. If you missed number 6, here is a quick explanation. So which of the following has negative 5 as one of its solutions? The quickest way to do this would be to graph it. So graph each quadratic and look for an x-intercept of negative 5. All right, so let's just quickly graph each of these. Okay, this one has an x-intercept of positive 5, so it's not A. Let's do B. Okay, that one has an x-intercept at negative 5, so our answer is B. Which equation states a rule for the pattern shown below? So what we're looking for here is the equation from the table. So in Desmos, add a table, put in your values, and then you type y1 squiggle ax1 squared plus bx1 plus c. And that gives you the a, b, and c value for the equation. So plus table, let's put in these values. So x is 1, 2, 3, 4. Y is 1, 5, 11, 19. Then in a new box, we're going to type y1, go to ABC for the squiggle, ax1 squared plus bx1 plus c. That gives us our a, b, and c value. So a is 1, b is 1, c is negative 1. So that means in our equation of y equals ax squared plus bx plus c, we just found the a, b, and c value, we plug them in. So 1x squared plus 1x plus negative 1, or just minus 1. And you can simplify that even more to just x squared plus x minus 1. So that is option B. If you missed number 8, here's a quick explanation of that one. So the table shows a relationship between the values of x and y. Write an equation that describes the relationship. So we are looking for the equation. That means in Desmos, we're going to put in the table. So you're going to do plus and click table, put in your values, and then you're typing in y1 squiggle ax1 squared plus bx1 plus c. All right, so plus table. Type in your x's. We have 0, 1, 2, 3, 4. And then we have -3, -2, 1, 6, 13. All right, now we want to get the quadratic equation from this, so we're going to tell Desmos to give us the a, b, and c value of the equation in standard form. So we're going to do y1 squiggle ax1 squared plus bx1 plus c. And that gives us a, b, and c. So our a is 1, b is 0, c is -3, and we plug those into the equation in standard form. So y equals 1x squared plus 0x minus 3, or plus -3. And we can simplify that a little bit more to just say y equals x squared minus 3. And that is our equation. Number 9, again, we are looking for the equation here. So we're going to put this table of values into Desmos. Our x's are -1, 0, 1, 2. Y's 1, 0, 1, 4. All right, and now we're going to tell Desmos to give us the a, b, and c value of the standard form of this equation. Just to remind you, in Desmos, to get the equation, you have to add a table, put in this table values, and then you're going to tell Desmos that you want something really close to the equation for this table. And you tell it that by typing it in Desmos language. y1 is similar to ax1 squared plus bx1 plus c, and we do that because in Desmos it says x1, y1 in your table, and we just have to make them match. So let's type that in. y1 squiggle ax1 squared plus bx1 plus c. And that gives us a, b, and c. So a is 1, b is 0, c is 0. So when we put that in our formula, or in our equation in standard form, and we're just substituting those a, b, and c values, so 1x squared plus 0x plus 0. We can simplify this so that it's just y equals x squared. Number 10, what is the equation of the quadratic represented by this graph? So the easiest way to do this would be to look at the points. So I would pick several perfect points from the graph and type them into Desmos in a table. So let's make our table first. We have the point 2, 1, 2, 3, 4. So we have the point 2, 4. We have the point 3, 1. Let's see, we have 1, 2, 3, 4, 0. 5, 1. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right, so in Desmos, let's tell it that we want to find the equation of this table. So we're going to add a table first and then tell it we want the equation. All right, so plus table. 2, 3, 4, 5 are our x values. And then 4, 1, 0, whoops, I missed something. 2, 3, 4, 5, 6. And then 4, 1, 0, 1, 4. Okay, so let's tell Desmos what we want. Y1 squiggle ax1 squared plus bx1 plus c. So our a is 1, b is -8, and c is 16. Plug those into the standard form of the equation, and we get y equals 1x squared minus 8x plus 16. And you can drop the 1 from in front of that x squared and just get x squared minus 8x plus 16. If you missed number 11, let's go over that one. So the figure shows the height of a thrown ball, as a function of time. So we have time and height in feet, so seconds and feet. Height is measured in feet, time is measured in seconds. How long will it take for the ball to return to the ground? So it was on the ground or close to the ground. It looks like it was between 0 and 5 feet when it was thrown. And it goes up, 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 and then it reaches its maximum at 2.5 seconds, its maximum height of 35 feet, and then it comes back down and hits the ground at 5 seconds. So it was in the air for a total of 5 seconds. If you missed number 12, here is a quick explanation of how to complete this one. So a pendulum hangs from a clock and swings over its base. So if you don't know what a pendulum looks like, it's, okay, so let's say it looks kind of something like this, okay? So here's the clock, okay? And then the pendulum is a little metal disc, and it swings back and forth. It swings back and forth, so it kind of like swings, 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 and then comes back down and swings around. So the pendulum makes kind of a parabola-shaped curve, right? It kind of swings back and forth like this. So here's some information we have. The distance between the pendulum and the base of the clock. So the pendulum is this pink line that I drew, and the base of the clock would be here. So base, pendulum. Okay. So the distance between the pendulum and the base of the clock, the distance is f of x, is modeled by this function. What is the minimum distance between the pendulum and the base of the clock? So what we're looking for is if this was our graph, so think if this was our x-axis, and let's say here's the y-axis. So if the x-axis is the base and the pendulum is the parabola, then what is the minimum distance between the pendulum and the base? In other words, what is this height right here? So what is the y value of the minimum? Okay, so we want to find that point and then look at the y value because y represents the height. Okay, so let's type in this function or this equation. I'm actually not going to type f of x. I'm not going to type y. You could type y equals if you wanted. And the important part is the expression, the quadratic piece of that. So 0.25 x squared minus 2x plus 10. All right, so that minimum point is 4, 6. So 6 is the minimum distance. 6 inches between the pendulum and the base of the clock. If you missed number 13, here's a quick explanation of that. A kangaroo in a single hop can reach a maximum height of 9 feet. That's interesting. The equation below can be used to determine height h in feet of the kangaroo's leap from the ground after t seconds. So let's say we've got, I'm not going to try to draw a kangaroo, but let's say I did. We have our little kangaroo, right? That looks pretty good, don't you think? All right, so we got our little kangaroo, and he hops. So his height is represented as a function of time. All right, so how many seconds would it take for the kangaroo to reach the maximum height? So the max, or the vertex, we're looking for how long, and time is our x value. So what is x at the max height? All right, we've got this function that represents it. So remember, in Desmos, you want to use x's and y's. So I'm going to say y equals negative 16x squared plus 24x. Whoops. And there we go. So our maximum is 0.759. 0.759. And we were looking for that x value because we're looking for time, which is x. So not even 1 second, he's already at the maximum height. I mean, I guess a kangaroo doesn't stay in the air that long. Okay, if you missed number 14, here is an explanation of how to do that one. An object is dropped from a tall building. Let's stop right there and just kind of get a picture of what's going on. All right, so we got a building, right? An object is dropped. So say someone's standing up here and they drop something. Oops. And then it hits the ground. Suppose the distance it travels is given by the formula, d equals 16t squared, where d represents the distance and t represents time. So time, remember, that's usually your x value, and the distance is obviously the y in this case. All right, how long does it take the object to fall 800 feet? Well, 800 feet, the feet would be the distance, right? So if d is 800, then we have 800, right, equals 16t squared. And now we're just solving for t, or x. So to do that, this is actually just solving an equation with just basic equation solving skills. So let's do this one by hand. 800 equals 16t squared. We'll divide by 16 on both sides. And let's see. 800 divided by, whoops, back up. 800 divided by, wow, I can't get this right. 800, there we go. Divided by 16 is 50. So 50 equals t squared. And now we can take the square root of both sides. So the square root of 50 is going to be a little more than 7, right? Because the square root of 49 is 7. So the square root of 50 is 7.07. And we don't want to use the negative, right? Normally we would say plus or minus the square root of 50, but we don't want to talk about negative amounts of time because that's not possible in the real world or in this scenario in particular. So we're looking at about 7 seconds. For number 15, here's an explanation if you missed that one. Carter is solving this equation by factoring, which expression could be one of his correct factors. So we just need to factor here. First, check for a GCF. Between 3, 10, and 8, there is no GCF. So we have to solve by slide and divide, which is part of factoring. So we're going to slide and divide here. So we're going to slide the 3 over to the 8 and multiply. So that gives us x squared plus 10x minus 8 times 3, which is 24. Now we can factor this. So what are two numbers that multiply to be negative 24 and add to be 10? Well, factors of negative 24 that would possibly add to be 10, I'm thinking 12 and 2. So 12 minus 2 is 10, and 12 times negative 2 is negative 24. So my factors are x plus 12 and x minus 2. Now I set each factor equal to 0, but not until I do my dividing. So at this stage is where you divide by the number that was in front to begin with. We've got to undo that multiplication. So if we simplify this, that gives us x plus 4, and since we can't simplify 2/3, the 3 will come in front of the x. 3x minus 2 equals 0, and now we set each factor equal to 0. So x plus 4 equals 0. Subtract 4 on both sides. X equals negative 4. Oh, we're going too far. We don't even need to solve completely. It's okay if you did, but we're just looking for the factor. So one of the factors was 3x minus 2. Number 16. Trinomials of the form ax squared plus bx plus c are not factorable if b squared minus 4ac is negative. So this is just giving you some information. If b squared minus 4ac is negative. So that means when you plug in a, b, and c into this little formula, if you get a negative number, you can't factor it. So it's asking you which one of these, if you plug in a, b, and c here, which ones would give you a negative number, because those quadratics would not be factorable. So basically all we're doing is we're going to plug in b squared minus 4ac for each of these quadratics. That means we need to know what a, b, and c are. So we have a, b, and c. All right, so let's plug it in and see what we get. B squared would be 2 squared minus 4 times A times C. And let's see what that is equal to. So that would be 2 squared is 4 minus, and then we have 4 times 3 times 6. Well, I can go ahead and tell you that 4 times 3 times 6 is going to be bigger than 4. So we're going to get a negative number, but we'll do it just to show you. So 4 times 3 times 6 is 72. So 4 minus 72 is definitely a negative number. So which of these are not factorable? Well, A is one of them, because we got a negative number for b squared minus 4ac. All right, let's try the second option. A is 2, B is 0 since there's nothing there. Let me write this out for you. Okay, so since there's no middle term, that's like plus 0x, and it was a minus 15. So b squared would be 0 squared minus 4 times a times c. So 0 minus anything is going to give us a negative, but you have to take into account that there's going to be some multiplication there that might end up giving you a positive number. So 0 minus, let's do 4 times 2 times negative 15. That gives us a negative 120. Now remember, 0 minus a negative is going to be actually a positive, so you're adding. 0 plus 120, which is positive 120. So this one looked like it was not going to be factorable at first, but be careful with your signs because this actually ended up being a positive, so that quadratic is factorable. All right, C. We're going to use b squared minus 4ac, plug them in, see if you get a negative number. All right, so a is 1, b is negative 3, c is positive 2. So b squared minus 4 times a times c. Negative 3 squared is negative 3 times itself, which gives us a positive 9 minus 4 times 1 times 2 is 8. 9 minus 8 is 1. That is positive, so it is factorable. I'm going to make a note of these. This one is not factorable. This one is factorable. This one is factorable. And then let's find D. D does not have a C value. It has x squared, x, but it doesn't have a C, so we can just write plus 0 and use our b squared minus 4ac. So b is 11 squared minus 4 times a times c. So 11 squared is 121 minus, now 4 times 4 times 0 is still something times 0, so that's just going to give us a big old 0. And 121 minus 0 is 121, which is positive, so this one is also factorable. So the only one that was not factorable was A. Number 17, if you missed this one, the function shown represents the height in feet of a rocket t seconds after being fired. What is the initial height of the rocket above the ground? So the best way to do this one, or the most efficient way, would be to graph it. You could use the box method, or use double distribution, or use FOIL, whatever you learn to multiply polynomials. You could multiply this out and put it in standard form. That would be pretty time consuming and leave you with a lot of room for mistakes. So we're going to use the tools that are available to us, graph it, find our initial height, and then move on. Remember that your initial height is the y-intercept. So y equals -5. Remember to use x's and y's here, not h's and t's. So x plus 2, close your parentheses, and a new set of parentheses opens, x minus 11. And this is a very tall, thin function, but we're going to go up to where we can kind of see where it crosses over the y-axis. Click on it and it will pop up with the intercept for you. And that intercept happens at the y value of 110. So the 110 is the y-intercept, or the initial value. So the initial height, or y-intercept, is at 0, 110. So that means after 0 amount of time, it was 110 feet in the air. The only way that's possible is if it was sitting on something that was 110 feet above the ground. And finally, number 18, if you missed this one, the function here models the approximate height of an object t seconds after it's launched. How many seconds does it take to hit the ground? So you're looking for that x-intercept that's positive. So you're looking for the x-intercept that is positive, and we're going to graph this to find that x-intercept. Remember to use x's and y's, not t's or f's. So y equals -5x squared plus 5x plus 10. And we're looking for that positive x-intercept, which is at 2, 0. So that means that after 2 seconds, the height is 0. So if the height is 0, it has hit the ground. So what this tells us is that it hit the ground after, or at 2 seconds.